Alex Coleman from University of Leeds. I believe he is one of the members of High Performance Computing. Here you go.
Hello.
The topic will be on reproducible notebooks for text analytics.
That's the one.
Well, there you go, Alex.
Super. So, good morning, everyone. I'm just going to start the old time because I appreciate I'm the last speaker before lunch, so you want me to be reasonably quick. So, good morning, everyone. I'm actually going to talk to you about a tool today rather than talk too much about text analytics, but don't worry, I've got some text analytics prepared as well. We're going to talk about reproducible notebooks for text analytics today. So when I say notebooks, we're talking about computational notebooks, not notebooks you're writing with pen and paper in. So bear with me as we'll get to that. But just to kick off, who am I, briefly? My name's Alex Coleman. I'm a research software engineer in the research computing team here at the University of Leeds. We're based in a central team in IT, and as we've heard already, we support the high performance computing systems here at Leeds, but we also do lots of other things supporting computational researchers across campus. My personal background is actually in Python and R programming, predominantly in sort of data science, with what I've described here as a sprinkle of natural language processing here as well. So I've done some projects before doing text analytics, and I'm going to show you a bit of text analytics in notebooks today because this is a text analytics conference, just to show you what it's all about. But firstly, if you're not sure what I'm talking about when I say what are notebooks, I'm going to just define it quickly for you. So I'm thinking about computational notebooks, which have become very popular in sort of the last 10 or so years. Now, computational notebooks are text documents that are typically made up of the JSON format, and it contains both code, markup text, and other graphical elements. That can be images, widgets, videos, plots, GIFs, whatever you like. And so we have sort of four main components. That said, I'll show you some examples. Now, the most famous of the notebooks, computational notebooks, is the Jupyter notebook. And I'm sure if we can have a quick show of hands here, I'm sure there are plenty of people here who have used a Jupyter notebook. That comes from Project Jupyter, who were inspired by this idea of sort of literate scientific computing, and based on traditional notebooks that scientists used to write, where you would both write your methods, you would write your notes, you'd stick your figures into a physical notebook, and they thought, can we transpose this into a sort of computational interface to do scientific research computationally? And that's where notebooks were born. Now, predominantly they're used for Python, but you can run all sorts of code in notebooks. Jupyter notebooks are the most famous. Then we've got Jupyter Lab, which is the sort of successor to Jupyter Notebooks. If you've used a Jupyter Notebook and never used Jupyter Lab, I recommend you have a go. I started using Jupyter Lab and I've never looked back since. But then we also have things like Google Colab, which is Google's own version of a Jupyter Notebook that they provide and give you access to computational resource in the cloud. And there are lots of other notebook offerings available. So notebooks are great for text analytics, it's worth saying. I'm going to do some quick examples of doing some basic text pre-processing all in a notebook. I will share the link to my slides at the end, but there's a link here to the original workflow complete with the topic modeling at the end that I've adapted this from. But I'm actually going to just drop out of my slides into a notebook now, so I can show you what it's about. So this is a notebook. It's made up of individual cells. Cells can be both markup text written in Markdown, or they can have code in them, or they can have other bits and pieces in them as well. So I'm just going to work through this, and this is why I'm going to talk to you why I really like notebooks for this sort of thing. So I'm going to go and get some data, and then I'm going to use some Python functions here just to load the data in the first instance. And this shows the first really nice thing about notebooks, which is that as we use them, if we wrote this all in a script, we wouldn't be able to have like a peek at our data just to check it's loaded correctly. We'd run our script and we maybe would get an error if it hadn't loaded correctly or something else. Whereas in a notebook, after every cell executes, we can return for us the sort of information that it's executed. So here in this nice example, I've loaded some data and I can just have a quick look at my data frame object in the first instance. So I'm happy that it's all loaded. this is some complaints data, consumer complaints data from America that I'm going to have a look at. I'm going to do some topic modeling on in this example. And I can do things like quickly do some data exploration. So in this example, I'm looking at how many words are in some of the complaint documents, or the mean number of words in the different categories of complaints in these consumer complaints. And you can start to really dig into your data interactively through the notebook. So I can also have a look at these explicit records. So I can see that the data is messy, as with all text data can be messy. I've got bits that are redacted. I've got things that are in sentence case that I want to be in lowercase. I've got punctuation and all that sort of things. I've got numbers. So we can start to do some pre-processing. And again, here within the notebook, I can separate my notebook into sections using these markdown sections. So I've said here, I'm going to start some pre-processing, and I've got a series of functions where I'm going to do basic pre-processing bits. So I'm just going to run those cells. I'm doing all sorts here. I'm just, lowercasing things. I'm lemmatizing words to their root. I'm creating n-grams, removing those redacted strings and all sorts of things. And so I can define these functions interactively in my notebook, which is really nice. And then I can just run those in this cell here. And then we can inspect this just to check we're happy with it. And I can compare the, it's just going to take a minute, isn't it? Because it's only a Tuesday and my computer's only just warming up. But what we can do is we can compare the original text to my pre-processed text. And we can say that we're pretty happy with this. We've got a nice list of tokens here that are ready to start our sort of text analytics workflow. And in this final step, I've just shown here another great feature of notebooks, which is that we can plot in line within the notebook. So here I've got a distribution of the counts of different words in this subset of complaints that I've pulled out. They're credit card complaints, funnily enough, and we can tell because, well, firstly, because I selected it above, but also the top two most occurring words are credit and card. So maybe we'd add those to our stop words. We could go back and make some changes, and we can start to do this sort of iterative, interactive programming with a notebook, which is great. But I'm going to jump back into my slides, and we're going to touch on the topic that there's a slight sticker in this, which is that notebooks can be hard to reproduce. So we can make our text analytics pipelines and share them as notebooks, but it can be then difficult for other people to take our notebooks and reproduce our results. So there's a number of reasons why notebooks make this particularly tricky in some cases. Firstly, this idea of hidden state. So let's take some cells. I could define a function that's just going to sum something, and I could run that function. And because of something else that's happened, if I now compare the contents of XX to 4, which we think it should be, I get false. Now, for those of you who've used notebooks before, you're probably going, I see what you've done there, Alex, because I can see the execution order here, 14, 15, and 17. So there's something in the middle that's happened that's changed the value of XX, which has led to this. And yes, you're absolutely right. There's a hidden cell here that I've hidden for this example. But the fact that you can do that is a problem, and often leads to a place where we get this hidden state that leads to outputs we don't expect and often hinders reproducibility. So then we get this problem of naming notebooks. Okay, I don't know about you, but I've got plenty of project folders that have just lots of untitled notebooks in, because the default for when you create a notebook with Jupyter is that it creates an untitled notebook, which isn't very helpful and often means we get lost about where we've put various bits of our analysis. So that's often difficult for encouraging reproducibility, this default behavior of giving it untitled as a name. We also often have this problem of when we share a notebook, we don't always share the dependencies that we need. So the packages that we might use in our notebook. Module not found error for those who aren't Python programmers is what happens if we don't have a third-party module installed, and it's often real annoying when it happens. We also don't typically write tests in notebooks. Now, I'm a research software engineer, so I love tests, and I would actively encourage everyone to write tests for their code because it helps make sure that your code is reusable and reproducible and actually does what it says on the tin. But notebooks don't encourage us to write tests typically. And so often when we get code that's shared in a notebook form, things might not work as we wish because we haven't written those tests to make sure it behaves in the way that we want it to. We also get this problem of not sharing data with notebooks. Often, we do analysis in our notebooks with some data that's on our system, and we don't always remember to share that with our notebooks. Sometimes we can't share it with our notebooks. That makes it difficult to reproduce those notebooks. In this example at the top, you remember I had that cell which actually went and fetched the data. That's one of the things that you can think about in your workflows to try and avoid this problem. But not sharing data is one of those key problems with making sure our notebooks are reproducible. But don't worry, the gist of my talk is that actually there are things that you can do to help improve the reproducibility of your notebooks. So the first thing I would always say to people is, should it be a notebook, or should it be a script, or should it be a library? I don't have a good rule of thumb on this because it's really something that you need to decide for yourself. But often it's worth thinking, am I just going to do some data exploration of a data set? Or am I going to do something where I'm doing a series of experiments over and over again, where I'm unlikely to change too much of the code, and I don't need to peek at the data at every step, I just need it to run my experiment? If you're the latter, then you should probably write a script or a library, and you probably shouldn't use a notebook for the reasons that we've touched on. So you should always have a think about, is a notebook the right answer to my problem? Okay, sometimes it will be, but sometimes it might be better to write it as a script or a library instead. There are also amazing tools available to help you validate your notebooks. So I talked about the fact that we don't typically write tests for our notebooks. Well, someone went away and wrote this amazing plugin for the PyTest package called NBVal, which lets you validate your notebooks. What do I mean by validate? Well, it takes the notebook and the cell output that is generated and embedded into the notebook, and it runs a test to see that if it executes those cells, does it get the same output? And so it's a way of, I would still encourage you to write tests, but it is another way of trying to validate the outputs you generate in your notebooks, okay? And that's a nice way of at least checking that your notebook behaves in the way you expect. There's also some great tools to help you get reproducible notebooks. There's this experimental tool called Julinter, which is a plugin for Jupyter Lab, and it provides you with input, or it provides you with a panel here that gives you tips about things that aren't quite helpful. So it tells you when there's hidden state, it tells you if there's a bad title, and it gives you other suggestions around things that might be unhelpful for reproducibility. There's also tools to help you reproduce your notebook. So Binder is a really great open source example of a tool where if you have a GitHub repository that has notebooks in it, you can point that repository at Binder and tell it to launch, and it will spin up a live in the web version of the notebook that you can run, you can explore, and it will install all the right dependencies. And as long as the data is embedded in that repository, it'll have the data available too. And what you can do with this is you can run this for your own notebook repositories and add a little badge that lets you launch it in Binder so that other people can really easily reproduce your notebooks. There's also a tool, if you don't want to go all the way of Binder, called Repo to Docker, which lets you convert your notebook repository, your folder of notebooks, into a Docker container, a Docker image that's Jupyter ready. So anyone can run that Docker container and it will run your notebooks in it, and they can play about with your notebooks too. So there's some really great tools for aiding with making your notebooks shareable, portable, and also reproducible, and some ideas to make that happen. So why not, for your next notebook, try naming it before you start, making sure you clear the outputs when you commit it to version control. Another issue, which I didn't touch on too much, is that because it's in JSON, if we commit things to Git or to GitHub, it often has really big information because you're changing this JSON document rather than it just committing the code changes. So maybe clear your outputs first to commit it to version control. Often makes it a lot neater. You could also, if you don't want to go the way of NBVal and validating your notebooks, just make sure that your notebook always runs without errors if you click the Run All button at the top. That's another good way of making sure it behaves as you expect from running top to bottom. And the last one, make sure you specify your dependencies. So whether that be the data that is needed to run your notebook that lives in the same repository as your notebooks, or those packages in either a requirements.txt file or a Conda environment or something like that. So specify those alongside your notebooks, and that will help make them reproducible. So thanks so much for listening. I hope you found this useful. I will share the slides with this as well, because at the end, I've got some links to these various things as well. This presentation is actually made using a tool called Rise via a Jupyter Notebook, which is quite cool as well. So thanks for listening, and I'm happy to take any questions.
Well, thank you so much, Alex, for the amazing tools that you just shared. I don't know if you have any questions. Yes, Bill, go ahead.
Thanks, Alex. That's a really interesting talk. So I teach data science, NumPy, Pandas, and Matplotlib, and so forth. So what would you recommend using if you're going to use a notebook? Should you use a notebook? Should it be Jupyter? Should it be Jupyter Lab? Should it be Colab? What would you recommend?
That's a great question, Bill. So I think for teaching, so for me, when we've done teaching of our Python course, we use Colab, because whilst I've gone through some of those drawbacks of notebooks, the sort of low barrier to entry that is Colab makes it really easy to get people on board. But it's just a core aspect of the teaching has to be to highlight those drawbacks potentially of notebooks, and also explain to people that if they're going to run this locally, they'll have to install NumPy, because Colab's got it already installed, and all those sorts of bits and pieces. So I think it's just making sure that we are as open as possible about the sort of benefits and drawbacks of when we use these tools for teaching. And I think that's absolutely fine. Yeah.
Okay, thanks.